Hello, everybody. Welcome to a quick lecture. Maybe not super quick, but welcome to a little lecture on LaTeX. We are going to outline a handful of things in this. We're going to look at Overleaf, which is basically a kind of Google Docs type of thing, but for LaTeX. We're going to talk about what LaTeX actually is. We're going to look at some examples of how you can use LaTeX really nicely. We are also going to learn some of the basics of LaTeX, and we're going to wrap up with talking about how we'll use LaTeX in our course. So without further ado, let's go ahead and jump right into this. So as you can see, I am on overleaf.com right here. I'm going to have posted registration instructions, kind of an outline of how you'll get into Overleaf. One thing to note, if you are watching this video before you've gotten into Overleaf, two things to note actually. One, I highly recommend that you get registered for Overleaf, that you get kind of to the same spot that I'm at, so that you can actually work along with me in this video, so that you can type what I'm typing and see what happens. So if you haven't done that yet, go ahead and pause the video and go register for Overleaf, get into the system and do all of that. And then you can follow along with me. But the second thing I'll note is when you actually register for Overleaf, and I emphasize this in a multitude of places throughout our course, but please use your student email, your front range email, to get into Overleaf. That is important for a variety of reasons, but I won't explain those here in the video. I'll explain those later. So as you can see right here, we are in Overleaf, and it has a nice layout. You can click here. I'm not going to, but you can click on all of the projects that you are associated with. You can filter it by just your projects or just projects shared with you, projects you've thrown in the trash, so on and so forth. We've got some nice organization here where you can give tags to things. So you can see these two lectures that are LaTeX lecture. I gave them a tag appropriate to that. Just kind of a filter, so I can click on LaTeX lectures. I could click on resume template, and I have things there. I can click on collaborations, and it shows collaborations that we have. We'll click through some of these and see kind of what's in them. But for now, we're going to start with this LaTeX lecture, an introduction, and get into that. And actually, now that I say that, I wanted to mention one quick thing. This is just a setting that I like to turn off, but this is up to you. If you come down here to account, this little image down here, you click on that, go to account settings, scroll down a little bit. These AI features, personally, I found them a little bit clunky and a little bit bulky, so I disabled them. I think for you, it'll say disable AI features. So I liked to turn that off, but that is up to you. There's also a ton of fun things here. If you use Dropbox or if you use GitHub, you can explore some of this and how to link those to Overleaf. I don't think any of that will be super important in our course, but if you decide to continue on and become a LaTeX master, those might be things that you utilize. So just a setting there, turning off that AI features, a personal preference on my end. But let's go ahead, let's click on LaTeX lecture introduction. This is something I've set up for us just to kind of work through here together. This is going to be very simple to start, but we are going to go through kind of the layout of a tex file, of a LaTeX file. You can see it's actually at its core very simple. But before we do that, I do want to go through some settings that I find very nice in Overleaf. So these are specific to Overleaf. If we come up here and we click on menu in the top left, you'll see a whole bunch of settings here. Most of these you don't have to change, but there are some things down here like the editor theme. I really like Monokai. It's basically dark mode. But this editor theme will sort of change. And I'll go ahead and do this. Watch these colors back here in the background. document class is kind of in a magenta, the 12 point is in orange, the begin and end are in blue. If I change this to Eclipse, it changes it all entirely. Now the background is white. We have totally different colors all here. You can mess around with these if you want, but I have found Monokai to be the best. So there's that. You can change some other things here. Font size is nice if you want to make the font way bigger. There we go. I may actually leave that a little larger there. So ton of things that you can change here, but those two in particular, the editor theme and the font size, I think are important. So with that out of the way, let's go ahead. We'll click back over here and let's just take a look at what Overleaf looks like. On the left side here, we can see our specific documents here. So these are all TeX files. TeX is the file extension for a LaTeX file. Down below this, we have file outline. There's nothing here yet, but we'll see an example of that. We've got in the middle here, the actual TeX file. This is where you would type. You can see I can type things there. And then on the right side, we have the PDF that is output from LaTeX. And of course, right here, you can see I typed hello and it says hello on the PDF. There's a whole bunch of things here. You can zoom in, you can zoom out, you can change the page number, you can recompile. There are some settings here that you can look through that we will utilize a little bit. I'm going to turn auto compile on right now, and that will automatically update this PDF as I edit the words in here. So if I type hello, this is a sentence, then it will automatically update that right there. Super neat. So we've got all this, but the question is, what the heck is an actual LaTeX file? And how does it work? How do we get it set up? What are kind of the minimum things that we have to have in order to start a file? The first thing that you have to have is you have to have what is called a document class. And by and large, you're just going to type this exact thing every single time you start a LaTeX file. / document class, bracket, 12 point, bracket, curly brace, article, curly brace. You obviously could change the font size if you want. And instead of article, you can change this to book, thesis, forms of presentations, lecture notes. There are so many different things that are built in to this. We're just going to use article. You can even create your own document classes. But what this document class actually does is it sets a framework for sort of the base settings, the basic preferences that you want of how you want your kind of bare bones project to look like. And for our purposes, we will use article all of the time. And so document class, that basically just, like I said, gives the initial settings for the LaTeX file. And you have to have that in order to start your file. I'm going to skip over this right here. We'll touch on this in just a moment. The second thing that you have to have in your LaTeX file is you have to have a beginning of the document and an end of the document. And the syntax here is important. I have to have a backslash. I have to have the curly braces. It has to look exactly like it does on line 5 and on line 10. And that right there gives us the sort of boundaries of where the LaTeX file starts and ends. And within the begin document and end document, you can type whatever you want. You can type whatever here. And as you type that, it will output it in the PDF right here. Then you can see that on the right side. You might wonder, why does this put it sort of, far to the right? Why doesn't it put it up where my cursor is right now? Why doesn't it center it? Why is there a page number 1 right here? Why isn't that page number 1 lower on the page? These are all settings based on the article document class. If I were to change this, and I won't, but if I were to change this from article to say book or thesis, it would change the basic layout of where these couple sentences went, whether or not there's page numbers, maybe even if those page numbers change from numbers to Roman numerals. But all of that is kind of wrapped up within article as a document class. So those are really the two things that you need. You need a document class, you need begin and end document, and that's how you start any LaTeX file. The third thing that technically is optional but is really needed is a preamble. And I have this commented out, and that actually brings me to another fun fact. In LaTeX, the % symbol is the standard for comment. So every coding language has a character that when you type that character, anything after that character on the same line is ignored. And right here, typing this % tells LaTeX to ignore everything on line 3 that comes after it. So I could go type random nonsense right here, and it ignores it. It still types it, but it doesn't do anything to affect the document. If I take this away, you can see it's not grayed out anymore. And now I am inputting this tex file called preamble2562.tex. You'll actually notice it edited some of the layout of this document. And the reason for that is that this preamble file, you can see it over here, and I'll click on it in a moment, has its own settings that override the article document class. So while this article document class gives you the initial framework for how the tex file and for how the PDF will look, this preamble file that I have created will overwrite some of those settings. So let's click on this preamble2562.tex file and see what it looks like. And I warn you, it's going to look a bit ugly. So when we click here, I can scroll down and there are tons of things in here. Think of all of these as just settings. And this scrolls down for hundreds of lines. I have created all this for use for our course, mostly so that you don't have to worry about all of these settings that we have. And the reason that I have put all of this in a separate file largely is because it's really long. But the more important reason is that if I didn't put this in a separate file, what I would have to do, and I'm going to do this, it's going to look terrible. I would have to copy and paste all of this, come back over to main.tex, and instead of this input command, I can copy and paste all of that right in here. And so you'll notice I have document class, and then I go through hundreds of lines of settings, all before finally hitting begin document and then the actual content in the file. I don't want to have to look through 285 lines of code and scroll down every single time I start a LaTeX file. So what I do is I just take all of this right here that I'm highlighting, and I'm going to delete it, or rather copy and paste it into a different file called preamble2562.tex. And then I just use the command \input, and I tell it what I want it to input. I tell it to input preamble2562.tex. And that just copies those lines of code, brings them right in. We're sitting pretty. So, very clean looking document that is not 10 lines long. It's actually like 300. It's just most of those lines are hidden inside this input command. Wonderful. With this, we have a document. I can continue typing more sentences on a new line, and it will continue outputting in the PDF new sentences on new lines. And honestly, you could treat this almost like a Word document at this point. You could just type whatever you want, and it will output it in the PDF. But before we get into that, before we start actually trying to branch out and type new commands and maybe even type some math, we got to talk about a handful of things first. And the most important of these are commands, environments, and restricted characters. I'm actually going to type all that out. Commands, environments, restricted characters. So all of these commands, environments, and restricted characters, we can actually see all of them in this file currently. Commands, one example is input. This is something that, and I'll be careful, \input. This \input is a command that tells LaTeX to take whatever is in this file and input it into the current file. And so honestly, right there, that is a simple example of a command. A simple example of an environment is this begin document and end document. That is we call it an environment because there are things inside of that environment, and that environment sort of sets the tone of what things look like inside of it. Environments always have a start and an end, a beginning and an end. And in this case, the necessary environment is to begin and end the document. We're about to see tons of examples of commands and environments, so don't worry if you're looking at these examples that are on here and thinking that they seem a little weird. We'll get there. Restricted characters, not obvious here, but there are actually a handful already here. One of them, the most notable, is a \. And the best way to see how this looks is to just try typing this. So let's type this out. The \, notice I typed that, is a restricted character. And let's see what happens. In the PDF file, let's zoom in a little bit, it typed out the \, there's a little blank space, and then it says is a restricted character. There's nothing in there, even though I typed a \, right here. Well, LaTeX uses \, if we want to phrase it this way, as a coding language. The \ is a character that LaTeX recognizes as the precursor to a command or an environment. So right here, when I type this \, LaTeX is expecting me to put something like \input. But since I don't, it just honestly doesn't know what to do. And so it certainly doesn't type a \. And so I call this a restricted character because this right here is this actual \ is not something that I can type easily, let's say, in LaTeX. Another example of this is a curly brace. We actually see curly braces over and over right here in the input command. The curly braces delineate sort of the start and end of the file that I wanted to call in here. Begin and end that environment, I put document, but I have to put it inside of curly braces. If I did not have these curly braces and I just said begin document, you can already see there's an error, invalid environment command. LaTeX does not know what to do because I have not told it what environment, in this case document, I have not told it what environment we're utilizing. So I could say the same thing. Let's do it. The curly brace is a restricted character. And we're already seeing some issues here. Code check failed in the top right. I have unclosed open group. I'm going to fix this by typing another curly brace. You're going to understand this much better later on. But let's just type both of these curly braces. Let's be grammatically correct. The curly braces are restricted characters. And let's see what types in the PDF. Again, we don't have those curly braces do not show up. And that is because you cannot type them without LaTeX expecting something to sort of go between them, if you will. Similarly, the ampersand is another restricted character. And let's see what this types out. Error, first and foremost. However, Overleaf is nice / maybe a little tricky, and it tries to compile even if there's errors. So right here you can see compile error handling. Stop on first error versus try to compile despite errors. I always recommend before you submit something to me to switch this to stop on first error, just to make sure that everything is working. But for now, I'm going to tell it try to compile, because I want us to see what happens. Again, there's no ampersand actually there. The question that you probably have is, how do I actually type an ampersand then? This is a case-by-case scenario, but for this particular restricted character, the ampersand, I can just put a backslash right before it, and LaTeX recognizes this in the purple as a command to type the ampersand symbol. If I don't have that there, there's an error, it doesn't like it, but if I put that, now it's a command telling me to type an ampersand. Similarly, and we're gonna see if I can improvise a little bit here. To type a backslash, type backslash backslash. We're gonna see if this works. I don't actually know off the top of my head. Wonderful. It gave me a small error here that we'll discuss later. Don't worry about that right now. But as you can see, it actually typed a backslash in the PDF, and I typed backslash backslash. Interestingly enough, we did not type backslash with another backslash. That doesn't work. So this is kind of what I mean by case-by-case basis. With ampersand, it is as simple as doing a backslash and then the symbol that you want. But here, I actually had to type the word backslash out in order for that to work out. Gave us some errors, but we're not worrying too much about those right now. So we're seeing restricted characters. You are going to get very familiar with what restricted characters, the variety of restricted characters that there are in LaTeX. But let's go ahead and continue on and talk a little bit more about commands and environments. I'm going to do a command right now, backslash, you saw me type clear page. That works, but I'm going to be a little bit more straightforward and type backslash new page. And then let's go, here's another sentence on a new page. And let's see what happens here. As you can see, we have the text that we've typed before, page number 1, but if I scroll down, I have a new page. Here we go, page number 2. So this new page right here is an example of a command. I preceded it with a backslash, and it tells LaTeX to go to a new page. There you go. There's a command. Wonderful. You know what? Let's start trying more commands, and let's see what happens. Another possible command is, and I'm thinking of one off the top of my head, and my improvisation is failing me here. Let's go ahead and try to type something math related. What about a square root? You might be able to do some Googling and find out that the command for square root is not just to type square root, that's just going to type the words, but I do a backslash to tell LaTeX I am doing a command, and I type sqrt. And if I do this, let's see what happens. You can see that it puts a square root symbol, but there's a handful of things happening here. First off, I have a little error on line 18. Secondly, there's nothing inside of this square root. And the reason there's nothing inside of the square root is that I did not tell LaTeX to put anything inside of it. So what I have to do is after this command, I put curly braces, and I can put something inside of that. And so whatever is inside that curly brace will go inside of it. I could put 4 100,000 inside there, and it will put it underneath that square root. And you can see that typing in right there. Now, what the heck is with this error? It says missing $sign inserted. This brings me to math mode and how we actually type math in LaTeX. And I'm going to sort of weave this idea into this whole lecture. But when we are wanting to type something math related into LaTeX, you have to tell it to switch from English sentences, words to math mode. There are a variety of ways to do that. The simplest is to type a $sign. And I'm going to do this one more time. I am only typing $1 right there, but Overleaf is nice and it types a second one. What these $signs do is they delineate the beginning and the end of math mode. I'm going to type out some more stuff. There we go. So we have this whole new sentence. Let's go ahead and just read through it. Here's another sentence on a new page. Another possible command is, hey, LaTeX, go into math mode. Now type the command square root of 4, which is a math command. Now go out of math mode, comma, English, 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 which we know is equal to, hey, go into math mode, type 2, then exit out of math mode. And you can see in this PDF, it looks super clean. It bleeds right back and forth between English and math. It looks great. There's no issues. Overleaf isn't giving me any errors. Wonderful. Of course, if I take this away, LaTeX is going to basically yell at me and say, hey, \square root is a math command. You're missing a $sign. You have to put this wrapped in $signs. Again, the first $sign telling you where to start, the second $sign telling you where to end. And there we go. There's an example of a math command, but we're really starting to see the first big idea with LaTeX, that you have to tell it when you want to go into math mode and when you want to just be in normal English language. Interestingly enough, I put this 2 in math mode. I don't have to. In this case, there's not really anything wrong with either of these. You can see in the PDF, it doesn't look any different. It's really only when I actually type a command or a math command that I have to be in math mode. So there's that. There's some examples of commands. Let's keep going with a handful. Let's go into math mode here. Let's type \abs x minus 3 \abs. And we can look at what this does. Little error here. I've maybe made some mistakes here. Let's try to clean this up. Maybe I need. Let's just try that. \abs of x minus 3, and you can see very nice and cleanly it types the absolute value of x minus 3. And so we're seeing here that absolute value is not a standalone command. And what I mean by that is it requires an argument. It requires something to go inside of it. If I don't put that x minus 3, if I just type \abs, it produces an error. It doesn't know what to do. It's giving us all sorts of issues. But if I put that x minus 3, then there we go. Let's go on to a new line. Let's type something a little different. Let's go ahead and type \vert. \vert, as you can see right here, it just typed a vertical bar. You'll notice, however, this is a command that does not require any actual argument. I didn't need to put stuff inside of curly braces because this command does not require it. As you continue to explore and understand various commands in LaTeX, I'm typing out a whole bunch right here. You'll notice that some of them require arguments and some of them don't. We've seen two right here, square root and absolute value, that require them. But here you can see I'm typing greater than or equals to, less than or equals to, not equals to, and all of those don't require any actual argument following them. This leads me to optional arguments. What if I have a command, and actually a great example of this is square root. What if we type square root of x? Let's see what it outputs in the PDF. Square root of x. Nice and simple. But what if I wanted to do the cube root of x? Now you might think that I could go type cu instead of square root, but I don't want to do that. What we're actually going to do here is we're just going to type it and then we'll just analyze it. We'll see what happens. I typed some extra stuff here, and you can see that it puts a cube root right there. And of course, if I change this 3 to, say, a 31, now it's the 31st root of x when it updates. That does look a little weird, but let's do like the 5th root of x. And this should look nice and clean. We have the 5th root of x. What we're seeing here is that square root is a command that requires an argument. So I have to put what I've highlighted here. I have to put curly braces with something inside of them. If I don't do that, it's deleted now. We run into issues, red errors, missing, blah, blah. We don't like this. So I have to have that. But what we're also seeing is that I have what's called an optional argument. Optional arguments, 99% of the time, are enclosed with square brackets as opposed to curly braces. And they, again, 99% of the time, they precede the mandatory argument. In this case, putting that bracket 5 close bracket changes the square root command to not be a square root anymore, but to be a 5th root. If I take this away, it's an optional argument. I don't have to have it. Well, there we go. Now it defaults to what LaTeX has deemed the default, right? There are plenty of commands that have... so I'll rephrase what I said before. There are plenty of commands that have no need for an argument, greater than or equal to. There are plenty of commands that have that need an argument, like absolute value. And there are also plenty of commands that need an argument, but also can take an optional argument if you want them to, such as square root. I'm not going to go through tons of examples here. You can explore these at your own pace, but here we go. We're seeing commands. We've kind of flushed these out. There are an unbelievable number of commands in LaTeX, both in math mode as well as out of math mode. We're seeing new page, input. These are commands, even this ampersand for the restricted character stuff. Those are examples of some commands that have nothing to do with math. And then we're also seeing, of course, as we've been dealing with, many math mode commands. So we have all that. This seems like a good time to go to a new page, and let's type some more things. And let's go ahead and scroll down to our new page once the PDF recompiles. Sweet. So from here, we're going to look at environments, and we've seen one of them so far. It's the begin and end document, but we're going to see a better one. To type a bullet point list, see below. And let's watch what I actually type in the text file right here. To do a bullet point list, I need to create an environment. And by creating this environment, it effectively tells LaTeX, hey, there's a beginning and an end to this. And really, it's just the beginning of the bullet point list and the end of the bullet point list. And how we do this is we'll type a \begin. And there's a fun thing in Overleaf here. It tries to autofill. I'm going to scroll through this a little bit. You can see there are tons of environments: figure, gather, itemize, multiline, quote, split, tabular, verbatim. There's tons of these. If I click this top one, oh, it's not really liking it. Well, it won't let me click that top one. But we're going to type begin, itemize. Now we're going to click that. Kind of all over the place here. I apologize for that. Let's just look at what I've typed here. I have set up this environment called itemize. Now, you're not seeing this in the PDF, but the itemize environment does a bullet point list. We'll see that in a moment. But this right here is the framework for starting and ending that bullet point list. Now, when I am in this particular environment, if I type \item and then some words, let's see what happens. It starts a bullet point list with that item. And I can keep going here. My first item, my second item, my third item, and we can see it making a bullet point list right here. This is one of the simplest examples of an environment. I have told LaTeX to begin and end a list, an itemized list, and I have told it what I want these items to be. Now here's where things can get fun. If I want to change this from a bullet point to, say, oh, I don't know, a square root symbol, I can do so with an optional argument that follows the item command. And now this is going to look really, really funny, but imagine you had a bullet point list where instead of bullet point dots, the bullets were square root of x every time. Of course, you probably would never do that. You'd probably do something like an asterisk \AST. And you'll notice I am doing this in math mode. I'm not really going to emphasize why I'm doing that, but this is an option for you to change your bullet points and what they look like. The itemized environment has so many ways that you can customize it. I'm not going to go into all of them now. I just kind of want you to see what this looks like. But here we go. We have an itemized list right there that's a little customized. Let's keep going. To type a numbered list, see below. We're going to do pretty much the same thing. I'm going to do \begin. I'm going to do my curly braces, and I'm going to type enumerate. And here's what's actually fun. At this stage, you can see Overleaf is trying to autofill, trying to help us out. It'll autofill this enumerate environment. If I click enter right here, it automatically constructs that environment with the beginning, end, and the necessary item that I need. And I can do the same exact thing. And you can see in this case, the list is just numbered rather than bullet pointed or asterisks as I've changed that itemized list. So these are environments. Itemize and enumerate. These are two actually of the most frequently used environments that you will use, not to be outdone by a math mode environment that we're going to see. There are plenty of other environments. A fun one actually is begin comment. And I hit enter, you can see it automatically. Overleaf is nice. It types end comment for me. Whatever I type inside of here is commented out and will not appear in the PDF. If I type outside of the comment environment, it shows up on the PDF. And you can see right here, it goes right from this itemized list straight into that sentence that I typed right here. It skips over all of this stuff because I told it to comment it out. So if you had a very large chunk of code that you wanted commented out, instead of putting that percent sign in front of it like we did before, you can, here, I'll do that here. I could put a percent sign and it grays out that line, and now that sentence is going to disappear from the PDF. If you didn't want to do that for hundreds of lines, you could just wrap all of it in a environment, in the comment environment. So we have that. That's awesome. As I've said, there are so many environments. If I type begin, you can see there are tons of them. And this isn't it. This is just the ones that Overleaf is deeming important enough to try to help us with some autofill. So we have a ton of stuff there. Let's go ahead. Let's go new page. That seems like a good place for a new page. With these environments, just like commands, they sometimes require arguments to them, and they sometimes can take optional arguments to them. We're seeing a handful of environments here which do not have to have they don't have to have arguments after them, but I'll give us one that does. If I do begin multicall and then end multicall, you can see I had to put a 2 right here. And fun enough, what this actually does, let's go some words, more words. Let's see what actually happens. Let's scroll down here. Sorry, it's multi-calls, not multi-call. There we go. This will look better. So what this environment does, multi-calls, is it takes everything that is inside of it and it will split it into a certain number of multiple columns, multi-calls. In this case, it is splitting it up into 2 columns. If I want to split this into 3 columns, it will do so. This might look a little weird. There's 1 column here, a second column in the middle, and there's a third column that there's nothing in it. But if I were to type another sentence, you'll see that it will actually put a third column there. So that's nice. So now it's just basically doing columns there. But I have to tell it how many columns I want. If I get rid of that 3 right there, this environment now does not know how many columns to have, and it gives me errors as missing number because I didn't tell it to do 3 columns or 2 columns or however many you wanted. So multi-calls is an example of an environment where you have to have a argument there. Following it. Whereas enumerate and all these other ones above, we did not need anything right after enumerate. However, you are welcome if you want to put an optional thing after enumerate. And in the case of enumerate and itemize in a handful of environments, what can go optionally in where my cursor currently is are just basically settings for enumerate. I'm going to show one of them that is telling enumerate \label equals. This is going to definitely look a little weird. You don't have to worry too much about what I'm typing in here, what's highlighted. Just know that other than some errors, there we go, that's a little fixed. This right here is an optional argument that is telling the enumerate environment to label according to what I have typed right here. I'm not going to get into the weeds of this, but you can see I typed alf and all of a sudden it does some letters. I put some parentheses and it put parentheses around those letters. But the important thing is I have changed how this enumerate environment looks like by giving it an optional argument that basically is just some settings, just some fun settings for it. So again, optional, don't have to have it, but for multi-calls, you do have to have something there. Wonderful. Let's go new page. Let's continue typing, and let's just continue on. So we've seen commands, we've seen environments, we've seen restricted characters, but what we still need to really get into is math mode. So this page will talk about math mode. We saw this a little bit. I'll scroll up. We saw that in order to type, say, a square root symbol, we had to enter into math mode. And the way we did that was with $signs. So I'll go ahead and type out. One way to enter math mode is with single $signs wrapped around your math. For example, $, I'll just do square root again. There we go. And let's scroll down. Let's look at the PDF. Let's see what happens here. We get that square root of 4 right there. So that's awesome. That's great. This is how you can, this is the primary way for how you can type math things inside of a sentence. I'll say the square root of 4 is my favorite mathematical operation. You know what? It's not square root of 4. You know what is? Sine of x is my favorite mathematical operation. You can see I typed \sine of x, and it wonderfully types sine of x on the PDF right in the middle of that sentence, and it looks awesome. Let's see what happens if I don't put the / for sine. It now italicizes it. As nice as you might think that italicized looks, that is not standard practice. So we need to tell LaTeX \sine, this is a command, so that it does not italicize sine of x. Let's keep going. Let's do e to the x is my second favorite function. Let's see what happens. Up in the PDF up here, we'll see that sentence being typed, and e to the x is typed right in it, super cleanly. It looks great. This is wonderful. These $signs are super powerful. There are other ways to enter into math mode other than doing these $signs. I'm not going to tell them to you now because I want you to use $signs because it's the best. And that's my personal preference, but that's what I'm sticking with. I think you will find that the $signs are the most functional way of typing math inside of a English sentence. So we're going to stick to that. Let's continue though, and let's ask ourselves, what if I want to type math kind of on its own? What if I want to type math outside of a sentence? What if I have like 7 lines of work that I want to do? Well, let's start typing. In order to type several lines of math at once, we use the align environment. So this is an environment. Let's put this in quotes right here. This is an environment, just like multi-calls, just like enumerate, just like itemize. Again, I'm going to emphasize, there are other ways to do what I'm about to do, but the align environment is by far the most robust. It is the best. It is the most useful. So in this video, I'm not even going to show you the other ways. Because I want you to be using the align environment. So Let's go ahead and do this. We know, we don't know what the align environment necessarily does and its intricacies and how it works, but I do know that it is an environment and it is called align. So if I type \begin align and then I type end align, I've got the bones of it. This is wonderful. And now, presumably, there's some stuff that needs to go inside of this. Just like before, on enumerate and itemize, I had to type \item in order for it to know to put a bullet point or a number there. So, and you can even see right here, it doesn't like, it's giving me errors in red that there's nothing inside of this align environment, but we will remedy that. Let's type f of x equals sine of 3x plus e to the 4x. Zoom out a little bit there. Wonderfully done. It puts a line of math right there. You can notice on the e to the 4x, I wrapped that 4x in curly braces. There's some fun stuff happening here. It didn't type the curly braces, which is cool, but let's do it without the curly braces. If I type e caret 4x, in this case, it only puts the 4 in the exponent. And so these curly braces around, let's do even better, 4x plus 3. Those curly braces delineate the start and end of what goes above that e, right, in the exponent. But I digress. We're looking at an align environment. There is a line of math right here, and it types it out so beautifully right here. And even it labels it for us. It says, hey, this is equation 1. There we go. Well, what if I want to do another line of math? What if I have a second function, g of x? I can go down to a new line, and I can type g of x equals x squared plus cosine of x. And we're going to notice something funky happen. In the PDF, it did not go to a new line. It just typed it right there. Unfortunately, when you are in math mode, LaTeX gets a little dumb. It kind of doesn't know what it's not smart, let's say. In this case, because I am in this align environment, LaTeX does not know that I want this to be on a new line unless I explicitly tell it to. And the standard way for doing a new line, for forcing a new line in math mode, but also even outside of math mode, is to do a double backslash in a row. We're going to see this all of a sudden puts that new line g of x right below. It labels it as equation 2. It types it wonderfully. We have h of x as another fun function that's just 4x. And we'll see that type out. It's going to label it equation 3. Right here, you could envision if I had some algebra that I was solving, solving an equation for y, let's say. I could do all of this on various lines inside of an align environment, and it would output all of it. In fact, why don't we try this? Let's go begin align. Little autofill there. Let's take 2x plus 3y equals 6. New line. Let's go 3y equals 6 minus 2x. New line. Y equals 2 minus. Now I need a fraction here. Luckily, to type a fraction, I can type \frac. Overleaf is wonderful, and it does some autofill for us. I tell it, ooh, PDF freaked out a little bit there. I tell it what I want my numerator to be, in this case 2. I tell it what I want my denominator to be, in this case 3, and then I can type the x right after it. And here we go. This looks wonderful, right? So we've solved for y, and then we can see the line right there. There are a handful of things that look a little weird in here, and we are going to edit these. But there's two notable things. One, I don't want to label every single line of math that I do in a LaTeX file. That's going to get awkward. It's going to look cumbersome. It's going to be weird. So how do I do that? How do I fix that? Well, there are two ways you can do it. You can manually, on a particular line, do the following command, \no number. And we're going to see this 2 disappear right there. Right there, it has not labeled this g of x line of math with a number right there. And I can keep doing this. I can go no number, and there we go. That's all fine and dandy, but honestly, that's not a scalable solution. If we had 400 lines of math in a file, that doesn't really help us. So let's get rid of that, and let's look at a quicker way of doing this. If I change this align environment to an align star environment, that star, that asterisk, will remove the labeling. You can see on the bottom, on the second example, it did not remove that labeling. So there you go. There's some good examples there. So largely, actually, you're mostly going to use the align environment. You're going to use the align star environment. And in the off chance that you feel like labeling an equation, you'll use the align environment and then maybe pair that with some \no numbers on the lines you don't want labeled. So that fixes one problem. But the other issue with this is that, honestly, this math doesn't really line up very well. And this brings me, actually, ironically enough, to why is this called the align environment? There doesn't seem to be much aligning happening, other than it is actually aligning all of this math up on the far right edge. You can see that very cleanly. If I edit this 4x and I go 4x plus 3, we're going to see nothing else changes other than just that third line. Everything is still lined up on the far right side. And you can see that too in this linear solving for y example. But with these functions, let's look up here at the f, g, and h of x. It maybe makes a bit more sense to line these up at the equal sign. And right there we're seeing, I want to align this at a particular location. So presumably there is a way to tell LaTeX, hey, line this up right here. And really, it's just as simple as a character. We've actually seen this character before. It is an ampersand. And I'm going to put an ampersand right next to all 3 of those equal signs. And we're going to see a wonderful thing happen in that math. It lines everything up according to that equal sign. If I even change the left side here, let's change it to y. We're still going to see it's still lined up on the equal sign, but now I have y right there. Heck, you probably wouldn't normally do this, but let's type a I'm not going to keep going. Supercalifragilistic, right? Let's type something really long there. Let's see what happens. It still lines everything up on the equal sign, even though there's way more text right here than there is on the f of x and the g of x. Doesn't matter. It still lines it up. Let's see what happens down here if I put an ampersand on all of the equal signs below. Nice and lined up right on those equal signs. And this is standard practice. We usually like to line up our math along equal signs. There may be cases where you don't want to do that, but for these simple ones that we're looking at now, we like doing that. So that's awesome. Wonderful. So we're seeing some alignment. Let's see what happens up here in the g of x. If I take away that alignment, it's going to be all sorts of weird. What it's actually doing is it's aligning the right edge of this g of x line with the equal signs of the other lines. What if I put the ampersand in front of the cosine? Well, it's going to line up the cosine with the equal signs. And you can see that equals, cosine, and equals are all perfectly lined up with one another. So some fun examples there. You can mess around with this and try different things. But for the most part, you are just going to use that ampersand to line up things along equal signs. And this actually answers a question you may have had a while back. Why is the ampersand a restricted character? Well, we're seeing it now. Back up at the top, I was not allowed to just type an ampersand. Everything freaked out. We'll see it right here. If I do this ampersand, it just says, misplaced alignment tab character. It thinks, it being LaTeX, thinks that we're trying to do alignment right now, but I'm not. I just want to type an ampersand, hence why I had to do the \ampersand. So it's a restricted character because to align things in LaTeX, you use the ampersand. So there you go. Wonderful. I'm going to emphasize again, we have seen two different ways of typing math. You can type math in the middle of a line of English, or you can type some English, break out of that, and type math explicitly on its own, bunch of work in a row. One thing I want to emphasize here, you're going to hear me say this a lot throughout the course, but we are going to need to be very, very good about switching back and forth between English and math, and back to English and back to math. And I'm going to show you examples of this, but for now, just kind of keep that in your head that is going to be important. So, this right here, honestly, is the bulk of what you need to know to really get started in a LaTeX file. Honestly, this last page right here is a great example of what a LaTeX file, of what a PDF might look like for you. But with that, why don't we actually take a look at an actual PDF that I have made for this course. Up here, I have harmonicoscillators.tech. This is a very long tech file that we'll look at. Let's go ahead and click on it. I'm going to recompile so that it produces that PDF. And we're going to take a look at this and see what this looks like. And honestly, primarily so that you can just see what this all looks like at the end, right? Kind of a finished product, how nice this can look. Maybe it gives us a little bit of motivation for why I'm teaching you LaTeX as well. This is going to take a little bit of time to compile, so bear with me there. But we can actually see, while we're waiting for this to compile, we can see that the start of this is all very similar to what we had before. We have a document class. We've input the preamble file because I didn't want 300 lines of code in the beginning of this. For purely organizational purposes, I have some commented out lines that really just serve as like a good break, a visual break in the actual text file. And then I have begin document, and then I just start typing. And if I scroll, oh boy, is this a long file. I apologize for any motion sickness there. Let's keep scrolling down all the way to the end. At the very end, hey, look, end document, 1,000 lines later. Wonderful. So back up to the top. You know what? We're not even going to look at the text file. We are just going to scroll through the PDF a little bit. You see, I got a nice cover page with some titles and my name. We've got contents right here. Ignore these page numbers. There's some funky stuff happening there. But we have a table of contents. Fun enough. You can see this highlighting. This is all hyperlinked. I can click right here on particular solution overview, and it takes me right to the particular solution overview page, which has a whole bunch of stuff here, which we'll see. Let's scroll back up though. As you can see, I have section headers. I've got equations labeled. I've got math mode. I've got English. I've got math that I'm actually doing. I'm defining constants. All of this done in LaTeX. We can even see some fun things here. If I look right here, I've got these 4 things of math. All of this is done in an align environment. Now, this is definitely sort of an advanced align environment. You can see I've got a whole bunch of ampersands in here. Honestly, this whole thing kind of looks a little ugly, if you ask me. Wonder if I can make that a little smaller. That looks a little better. One big long line. Oh, yikes. That doesn't look good. It looks ugly. That's okay. We'll get better at it. Excuse my zooming there. The point being, this looks nice and lined up. It looks very clean, and I did this with an align environment. You can see the R equals with all this quadratic formula looking stuff right there. It's lined up on the equal signs. Well, guess what? Look right here in the text file. I have an align environment with an ampersand equals on both lines, right? Looking all nice and wonderful. We keep scrolling. I have lists, a mixture of enumerated numbered list with bullet point itemized list. You could pause the video if you want right here and see how I have sort of blended together enumerate and itemize within one another. It's awesome. It's super nice. We can see wonderful boxes here. I have a environment. It makes sense that this note that I have here would be an environment because it's a box that I have typed stuff into. So I need to tell it, hey, here's a box, but there's a start and an end to that box. And I do that with this environment that we have not seen before called begin T color box as well as end T color box. I can keep going. I can keep scrolling through this. There's so many things. I can have a wonderful graph right here. This graph looks awesome. It is contained within an environment called TXZ picture, which you don't know yet, but I will teach you at some point. And there's commands to graph that. This all just looks really wonderful. I wonder if I can even find another thing here. Similar to case 1H. If I click right on that, it takes me to case 1H right there. If I scroll down a little bit more, let's find another example. Equation 6 right here. I'm gonna do this. That 6 right there, you can see it might be a little hard, but that is a hyperlink. I can click on that. You know what? I'm gonna click on equation 1. That's a little better. If I click on that, it takes me right up to the equation that I've labeled as equation 1. All of this is very advanced LaTeX. This is stuff that you will slowly learn over the course of this class, and you will continue to do it, I hope, after this class. But I'm just kind of showing you what this can look like. I love scrolling down even further down here. We get awesome math. You can see how I'm blending back and forth between English and math. I'm never going too far into a whole laundry list of algebra. I'm explaining what I'm doing in words. Not to toot my own horn, but a very, very, very well produced mathematical document right here. Some summaries here with some big equations. We love it. It looks wonderful. So that's enough of kind of looking at a sample document here. But just kind of want to show you what this can look like. With this, you are actually going to have an assignment, a sort of homework assignment in the very beginning of our course that teaches you some of the basics of how I want you to organize your LaTeX files. As I've said, I am weaving back and forth between math and English. I'm using English to explain my reasoning and what I'm doing. There is a way to do all this that is expected, that I'm going to expect of you. You will slowly get better at that as the course goes on. I will slowly get more strict on that as the course goes on. But there is a homework assignment that will outline how I want you to do all that. So keep an eye out for that because I'll definitely have announcements posted there. So let's go back to main.tech. We have been dealing with this extensively. This is wonderful. One of the last things that I want to do before we look at how we're actually going to utilize LaTeX in this course is I want to look at this preamble file just a little bit. So if I come over here and I click at preamble, you can see a very long list of things in here. And I just want to give some brief explanation as to what all of this actually is. You are not going to really have to mess with this preamble file, but I do think that it's important to see what it's comprised of. The first thing are packages. These packages are just more examples of things that you, like settings that you can change or things that you can do. Framed, for example, allows you to put a box around things. Multicall allows you to use the multicall command that we use to put things on multiple columns. So on and so forth. We even saw T-color box in the harmonic oscillators document, that kind of sample document. If I don't put this line right here, I can't do that environment for T-color box. So on and so forth. Keep going. It's wonderful. Whole bunch of packages. But then, moving forward, I have actually defined a bunch of commands. We're going to look right here. These are wonderful commands. Again, you aren't really going to have to deal with this, but new command is a way for me to create my own command in LaTeX. You know what I'm going to do? I'm going to copy and paste this into IX. We're going to come back to main tech. We're going to go to a new page. And we're going to see what happens when I copy and paste this. Now, you might be able to guess, this is an integral, int, that is indefinite with x as its variable. Integrals, however, require a function, an integrand on the inside. So this command that I've created takes an argument, and you can see nice and wonderfully, it spits out an integral of x squared with a dx right there. You want this to be a definite integral? Well, change that I to a d, and now definite integrals require bounds. So I put arguments in here, right there. Wonderful. And now it looks all nice and clean, a definite integral. You want this to be t instead of x. Change that x to a t. Probably change the integrand to a t as well. And there we go. Nice and clean. Same thing if you want to change it to a u. There you go. These are all commands that I have created, right? I'll even do another one. \pdiff with a numerator and a denominator. This will do a partial derivative of y with respect to t. Looks nice and clean. Again, these are commands I have created. You can see them all in the preamble. I 100% recommend that you scroll through all of these commands and familiarize yourself with them because there are a lot of them. You want to do a fancy script D for domain or range, you can do \d or \r. You want to type arcsecant, you can do \arcsecant. Funny enough, that's not a default command in LaTeX. I had to create that for you. If you want to type a vector that is bolded, I can do \bvec. If I want a vector with a hat on it, I can do \hvec. If I want a vector with an arrow above it, I can do \avec. I'm going to actually do that right there. Let's do another one, \avec v for vector. Let's see what that types. It's a bolded vector with an arrow right above it. Looks super clean. It's awesome. Let's keep going. So we've got commands here. Scroll down. Same exact thing as me creating commands. I've created environments. You don't need to worry about them for now. We're going to see them a bit more in a bit, but don't really worry about them. Honestly, most of the rest of the stuff here is just stuff you don't really need to worry about yet. What I do want to look at, though, is actually one of these packages, Comath, is a wonderful package, and I am going to utilize this a little bit. Let's go into, here is an example of Comath being used. That Comath package allows me to do a handful of new commands. These commands are super awesome. One of them is \del. And what \del does is it takes whatever you place inside of it and it automatically auto-sizes parentheses around it. Pretty much the same exact way I can do \SBR or \CBR, and it does the same thing, auto-sized, but with brackets, square brackets, or curly braces. This is an awesome, awesome command. Pretty much whenever you have parentheses around things or brackets or braces, you should be using this del command and putting the stuff you want to be wrapped with parentheses inside of it. So much so that I'm not even going to tell you the other way of doing it, because I 100% recommend that you do it this way. So that's only doable with that comath package being called, so keep that in mind. But there's that preamble. There's some fun examples of how it's useful, where we're using it. But here's honestly at this point kind of the end of talking about learning LaTeX and how we might use it, how we might actually learn commands and environments and all that stuff. What I want to wrap up with, and I know this has been a long video, so I apologize for that, but we are going to wrap up with how are you going to be expected to use LaTeX throughout this course. In this course, you are going to use LaTeX primarily for two different things. One are collaborations, and two are projects. I have a collaboration opened up already here, and we're going to take a look at what this looks like. This collaboration is basically a big Google Doc, a big collaborative file that we will all work on together and then give each other feedback. It is comprised of a bunch of questions. Here's question 1, here's question 2, here's question 3, all the way down. There's like 40 questions on this. And each of these questions will be solved by someone. There will be feedback given by someone and feedback given by someone else. And this is where your requirement comes in. For these collaborations, you are required to solve one problem and to give 2 instances of feedback. Hence why on all of these I have 1 solution box and 2 feedback boxes. I have an example of what a solution might look like. Here's a question. Given this matrix below, find its inverse. And I go through and I do all of the work for it. And then for fun, I gave myself feedback on it as well. And this is the level of work that I'd be expecting of you. You're going to have a handful of these collaborations throughout the semester. I don't expect them to take that long for you to do. But the nice thing is that with so many different people filling out answers to this actually gives you a great sort of study guide of worked out problems. And that's really the big purpose for this collaboration. So this collaboration, very, very big document. If I scroll down a little bit, we can see what one of these looks like in the actual tech file. So we have this question 1 right here. You can see I have an environment for begin and end question. And I type the question there. And then I have environments for begin and end solution, and then begin and end feedback. And of course, if you type your name in the optional argument there, it will say that that solution is authored by you. I need to recompile. There we go. You'll see my name pop up right here under the authored by in just a moment. And there we go. So you'll make sure to type your name in there so that I can have that for grading purposes. But you will just type your solution and your feedback right in these environments that I have created for you. There's definitely a lot of stuff behind the scenes going on here, but this just repeats. If I scroll down, you'll see the repetitive nature of these 4 environments: question, solution, feedback, feedback, so on and so forth. And there we go. So this is a collaboration. That's going to be one way in which you're going to use LaTeX. But the other way that you're going to use LaTeX is with projects. We're going to have 3 projects throughout the semester. They sort of increase in difficulty as we get from project 1 to project 2 to project 3. You are expected to do these in LaTeX, and that's largely actually why the projects get harder in difficulty, is because for this first project, you're new to LaTeX. I don't want to overload you with learning LaTeX and doing a complicated project. So the project is pretty easy itself. But basically in this project, you're going to partner up with a student, and you're going to read through. You're going to answer questions and read what I have to say, answer more questions, read what I have to say, keep going. I maybe do some math myself and do some explanation for you, and then you answer questions and you just keep going through. And it's basically like a guided activity that you'll answer questions and give me solutions for all of this. And then you will submit this tech file to me, this LaTeX file to me, and I will grade it. Fun enough, I will grade it in LaTeX. I will go through and I will write in the margins and color code and highlight things and say, this looks great, this could use some better formatting, and give you a bunch of great feedback, all within LaTeX, which will be super fun. So you'll have access to all of these from the start of the semester. But yeah, collaborations and projects. So, let's take a deep breath. That was a very, very long lecture. I appreciate if you've stuck around here. I appreciate it even better if you didn't throw me on 2 times speed. I'm definitely going to take a big drink of water at this point. If you have any questions with this, do 2 things for me. 1, email me your questions, but 2, don't panic. I've had a lot of students in the past that have seen all of this LaTeX at its first glance, gotten very, very nervous, very scared about how overwhelming it might seem, and then come back to me a couple weeks later and said, oh, this really is not that bad. LaTeX is not as daunting as it looks. It just takes practice. It really is a learn by doing type of language, and you can trust me that I would not throw you into something that I know you can't do. These collaborations and these projects, if it feels scary that I'm forcing you to do them in LaTeX, don't worry. I will guide you through it. It won't be as bad as it might look, but we'll work through it together. I will have several LaTeX lectures throughout the semester, and almost every class period, I will start off the class period giving you some fun, here's some new commands, here's a tip for LaTeX, here's something I discovered the other day in LaTeX. So we're gonna familiarize ourselves with it a lot. We're gonna get very comfortable with it, and at the end of the course, I will actually host a session where if you want to ditch Overleaf and install LaTeX locally on your computer, I will actually help walk you through how to do that, as well as why you might want to do that, and really be able to customize LaTeX to what you want it to be. So with that, I'm going to go ahead and end this video. Again, thank you for listening. Thank you for watching this. I've had a good time going through it, but definitely need a drink of water because my throat is sore. So, all right, we'll go ahead and close it there. Again, thanks for watching.